Right, so now we're going to be looking at finding the square root of a complex number. Very lovely. Now whenever we're finding the square root of a complex number, right, think about this. When you square root a regular number, when you square root a number like 81, when you square root 81, you get plus or minus 9, right? You get two numbers, that's the first thing. When you square root a real number, you get another real number. Alright? When we square root a real number, we get positive real number or a negative real number. So what are we saying? When we square root a complex number, so let z be a plus bi, we'll find the square root of z. When we square root that complex number, the result is also going to be complex. We just don't know what that complex number is. So here's the technique that we use to find the square root of a complex number. Think about it this way, right? If we're trying to find the square root of this number right here, right? So we have the complex number z is equal to a plus bi, alright? And we need to find out the square root of z. We need to find out the square root of z. So the square root of z is the square root of a plus bi. Now here's the first step to find the square root of a complex number. Step number one, let me put 1, step number 1, let the square root of a plus bi be equal to x plus yi. Alright, that's the first thing. What we're initially saying is, when we square root a complex number, we're going to get a complex number. Right? We just don't know what the real part is, or we don't know what that imaginary part is. So step 1, you let the square root of a plus bi be equal to x plus yi. That's step number 1. Step number 2 is to square both sides. Step 2, square both sides. When we square both sides, what we're going to get is a plus bi is equal to x plus yi all squared. That is step number 2. Step number 2 is square both sides. Alright? Now, the method, why do we do this method? By squaring both sides. Now, look at this. We have two complex numbers equal to each other. Now, if two complex numbers are equal to each other, what do we know? Then their real parts are going to be equal and their imaginary parts are also going to be equal. So now step number 3 is to expand the right hand side. Alright? So step 3, expand. When we expand the right hand side, you're going to have a plus bi equal to, expanding this is first term squared, x squared plus twice the product of the 2. This is 2xyi plus second term squared, yi all squared. Alright? That's what we do. Now look at this. Easy stuff now. Look at this now. Beautiful. Now we know that yi all squared is y squared I squared. But I squared is what? Minus 1. This part right here is y squared I squared. And I squared is minus 1. So this is going to become a plus bi is equal to x squared. Now I squared is minus 1, so this is going to become minus y squared. That's the real part, plus 2xyi. So a plus bi is x squared minus y squared plus 2xyi. Now once you get to this step, what do we do? Now look at this. If the two complex numbers are equal, then the real parts are equal and their imaginary parts are equal. So this is step number 4. Step number 4 is we equate real and imaginary parts. But we equate real and imaginary parts. What's so special? What is going to happen? When you equate the real parts, you're going to end up getting A is equal to x squared minus y squared. And we're going to have B is 2xy. Alright? That's what happens when we equate the real part and the imaginary part. Now by equating the real part and the imaginary part, we're going to end up getting a simultaneous equation where we can solve for x and y. When we find what is x and y, we can substitute those values back here, and that's going to give us the square root of our complex number. And that's it. That is it. That is it. That is all that we do to find the square root of a complex number. So now to do it, let's take an example, because when we do examples, it's going to seem a lot easier than it is. When you use letters, difficult, but we put in actual numbers, it's going to be way easier. So let's put in some numbers here. Alright, we're told to find the square root of the complex number 3 plus 4i. To find the square root of the complex number 3 plus 4i, it's very nice. All we have to do now is do what we said. Step 1, we need to let the square root of 3 plus 4i be equal to x plus yi. That's step 1. Step 2, we square both sides. Square both sides. So squaring both sides, we're going to get 3 plus 4i is equal to x plus yi all squared. Again, we expand out the right hand side, first term square, plus twice the product of the two, plus second term square. Alright, so that is what we have so far. Good. Now the next thing we said that we do is, remember I squared is negative 1. So this is really telling us that we have 3 plus 4i, and that's equal to x squared minus y squared plus 2xyi. Alright? Because I squared is negative 1. So now what we have is, this is our real part, and we're going to equate our real parts then now. Bruh. So now we can equate real parts. So equating real and imaginary. What we're going to have now is 3 is x squared minus y squared. 3 is equal to x squared minus y squared. And 4 is 2xy. 4 is 2xy. So now we get a case where we have a simultaneous equation to solve. Now let's just solve them simultaneously. We all know how to solve simultaneous equation. So we need to substitute one variable into the next. So let's divide both sides. Let's make y the subject. So we can divide both sides by 2x for the second equation. 2 over 2 cancel each other. X over x cancel, and so this is telling us that y is equal to 4 over 2x, right? But 4 over 2 is 2, so y is 2 over x. So now that we have this, y is equal to 2 over x, we can substitute y as 2 over x into equation 1. So we're going to sub this, sub into equation 1. This is equation 1. So when we substitute it in equation 1, we're going to have 3 is equal to x squared minus y squared. But y is 2 over x. So it's now 2 over x all squared. Beautiful. So let's simplify. Now simplifying, we get 3 is equal to x squared minus 2 squared is 4 over x squared. Now when you get to this step, we can multiply through by x squared. Alright, so let's finish off this step here. So we're going to multiply through by x squared. So bringing it here, So when you multiply through by x squared, we get 3x squared is equal to x squared times x squared is x to the 4. And then when you multiply 4 over x squared times x squared, remember, we're multiplying everything by x squared. We're multiplying both sides by x squared. So 3 times x squared, 3x squared, x squared times x squared, x to the 4, x squared times 4 over x squared, the x squared is going to cancel, so just leave minus 4. Now this part is leaving us with a what? It's leaving us with a hidden quadratic. Because this is then going to lead to, if we bring over the 3x squared to this side, we have x to the 4 minus 3x squared minus 4 equal to 0. That's what we're going to have. X to the 4 minus 3x squared minus 4 equal to 0. Alright? So let's take off this now and complete the rest of the steps. Alright? And all we're doing is solving this equation here. And by the way, make sure we have this down that y is 2 over x. Because when we find x, we're going to need to plug it into y to get what is the corresponding value of y. So this amount of space should do. So we have x to the 4 minus 3x squared minus 4 is 0. So we have x to the 4 minus 3x squared minus 4 is equal to 0. Alright? And remember, y is also 2 over x. So now we have all of the information. Let's clear down here too. Alright? So now we're solving this quartic equation here. Remember, x squared is a quadratic, x cubed is a cubic, x to the 4 is a quartic. So we're solving this quartic equation and realize it looks like a quadratic. So we can let m be equal to x squared. If we call it mx squared, then this is really m squared, because x squared squared is x to the 4. This is then minus 3m minus 4 equals 0. What can we do next? Factorize. Beautiful. Now we can just factorize it. So we have m, signs are different, the greater product is negative. So minus and a plus. This is 4 and 1. 4 and 1. Alright? So you can check it out. This time this is m squared. This time this is minus 4m. This time this is plus m. That would give you back minus 3m. So factorize it correctly. And so m is equal to negative 1 or m is equal to 4. Alright? So this is what we have so far. But what was m? M was x squared. X squared is equal to negative 1 and x squared equal to 4. Now guys, this part not valid. X squared cannot be negative 1. X squared cannot be negative 1. This one is not valid. How do we know that? X cannot be an imaginary number. Remember, x has to be real. Remember we said that the square root of 3 plus 4i is x plus yi. If we're calling it x plus yi, x will be an imaginary number. X has to be a real number. This has to be real. So therefore, this is not valid because x has to be an element of real. So left back with x squared equal to 4. So from this part, we square root it, x will be plus or minus 2. That will be x. X will be plus or minus 2. Now once you get x is plus or minus 2, we can find y. How do we find y? Come back to the formula. Remember we were solving the equations, it led us to y being 2 over x, right? So since we have y is 2 over x, this is going to be now, when x is positive 2, let's write it this way. X is 2 or x is negative 2. By writing it this way, when x is positive 2, y is going to be 2 over 2, which is 1, or when x is negative 2, 2 over negative 2, which is negative 1. Now once you get x and y, you're nice. You're nice. So now we can conclude, therefore, the square root of 3 plus 4i is equal to x plus yi. So when x is 2, y is 1. So one answer is 2 plus I, or we can tell him that the square root of 3 plus 4i is equal to, the second value is for x, negative 2. So that's negative 2 minus I. Those are the two possible answers for the square root of 3 plus 4i. Alright? Lovely. That's how we find the square root of a complex number. Now there's another way that we're going to do it, but later on when we talk about the different forms of complex numbers, we're going to see method 2 by using the polar form or the exponential form. Alright, so just some stuff to keep in the back of our minds as we progress forward. Really nice. But for now, this is how we're going to do it. Now, anytime you get an answer, you need to can check if your solution right, don't it? If I tell you that the square root of 81 is 9, then you suppose you can check and say, is 9 squared 81? Exactly. So we need to check to see if this is actually true. So always check your answer. So let's do a check here. This is a check. So we're just going to square these answers. Look at it. 2 plus I, we're going to square it. When we square it, we should get 3 plus 4i, don't it? Yeah. If we square it and we get 3 plus 4i, then we know we're correct. So look at it. First term square is 4 plus twice the product of the 2. 2 times 2 is 4, so this is 4i plus second term square, I squared. But I squared is negative 1. 4 minus 1 is 3. So look at that. We get 3 plus 4i. So what does that mean? That means that when you square 2 plus I, you get 3 plus 4i. So if we square root both sides, that means that the square root of 3 plus 4i is indeed 2 plus I. So that's our check with this one. And you can do the same for that one as well. Alright? Beautiful. So that is how we square root a complex number. Now you know we never leave it there. I'm going to put 1 for you to attempt. Alright? And if you get it right, you know that you're a champion. So take down this and then you can attempt the question that I'm going to put on right now. Really nice, by the way. It's going to be a nice example. Alright? Alright, so this is the question here. Find the square root of 24 minus 10i. So the clock is ticking. You may go ahead and do this question. Alright, so pause the video and attempt it. Alright, now let's go ahead and work out this question together. So we need to work out the square root of 24 minus 10i. We need to square root that complex number. Now whenever we're square rooting a complex number, remember what we start with, we just call it equal to x plus yi. Just call this equal to x plus yi. Easy. Then we square both sides. So we're going to get 24 minus 10i is equal to x plus yi all squared. Then you expand the right hand side. Expanding the right hand side, first term square plus twice the product of the 2 plus second term square. Alright, but I square is negative 1. So this is now x squared minus y squared plus 2xyi, and that's equal to 24 minus 10i. Then now we equate real parts. Equate the real part then together. 24 is equal to x squared minus y squared. And equating the imaginary, negative 10 is 2xy. Negative 10 is 2xy. Alright, so we equate the imaginary parts. Then now we're going to solve these two equations simultaneously for x and y. To solving these two equations simultaneously now. From the second equation, using the second equation, negative 10 is equal to 2xy. So we can divide both sides by 2x. Negative 10 over 2 is negative 5. And then 2x over 2x cancel. So that is telling us that y is negative 5 over x. Y is negative 5 over x. When we get y is negative 5 over x, we can substitute it into equation 1. So therefore, we're going to have 24 is equal to x squared minus y squared, but y is negative 5 over x squared. So that is going to become, this is now saying 24 is equal to x squared minus 5 squared is 25 over x squared. Then what do we do next? Guys, it's very repetitive. We just multiply through by x squared. Multiply through by x squared. And what we're going to end up getting now is 24x squared. Yeah, is equal to x squared times x squared is x to the 4 minus 25. Bring everything to one side. So let's bring this over here to get 0 is equal to x to the 4 minus 24x squared minus 25. Alright? This is our equation right here. Then now we can call x squared m. I like to use m. You don't have to use my letter. You can use u, you can use t, you can use v, you can use r, any letter you want to use. Alright? So let's just make some space. Just making some space. So the equation we have is x to the 4 minus 24x squared minus 25 equal to 0. And remember, it's from the two equations we had gotten, right? The two equations were x squared minus y squared equal to 24. And the second equation led us to having y is negative 5 over x. Alright? So solving this now, let x squared be equal to, just to change up things a little bit, let's say r. Alright? Let x squared be r. So this is going to become r squared minus 24r minus 25 equal to 0. So now we need to go ahead and solve this. Let's see if we can factorize it. 1 and yes, this can be factorized easy. So signs are different, the greater product negative, that's r and r, 25 and 1. Signs are different, the bigger number get the minus. Minus here, plus here. Cool. So therefore, r equal negative 1 or r equal 25. But r is what? X squared. Since r is x squared is 25, or x squared is negative 1. But x squared can't be the negative 1. X squared cannot be negative 1. X is a real number. So this part, again, not valid. So over here, we're going to get two values for x. We're going to get x is equal to the square root of 25 is 5 or negative 5. Beautiful. Now when you get x now, go back to this equation. Y is negative 5 over x. When you put 5 right here, we're going to get y is equal to negative 5 over 5, which is negative 1, or y is equal to negative 5 over negative 5 is positive 1. So therefore, we can conclude that the square root of 24 minus 10i, when you square root that, the result we're getting is either x plus yi, so it's 5 minus I, or the square root of 24 minus 10i is equal to minus 5 plus I. Those are the two possibilities. So you get either 5 minus I or minus 5 plus I. Alright? And that's it. That's how we square root complex numbers. Nice. Nice, 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 nice. So just a recap of what we did. Today we looked at adding complex numbers, subtracting complex numbers, multiplying complex numbers, dividing complex numbers, and we looked at finding the square root of complex numbers. So today we did computations of complex numbers. The next topic that we're going to do is solving complex equation. Meaning, on past papers if you look, or on the syllabus, you're going to see quartic, cubic, and quadratic functions and equations you're given to solve with complex roots. Alright, so we're going to do that next time around, so stay tuned for more. And also, you're going to see a worksheet being uploaded, and the worksheet that is uploaded is pretty much exam style questions and computation. So you may want to go ahead and also take a look at the worksheet video, but stay tuned. Alright, stay tuned for more. So I'm about to disappear. Alright, have some fun. Take care.